All right, welcome back, everyone. I'm wondering, so there were a couple of, I hope you had a chance to get a sense of how this would feel in a classroom. We didn't do the greatest job of modeling for you, like how you would fill out the slides, so apologies for that. We also noticed that somewhere along the line, some of the neurons got renamed, so I apologize for the confusion, but the underlying connectome is still the same. Yeah, so sorry about that. I would just say if you're developing your activities, just make sure that the creature as loaded in Crescent Loom is the same as the document that you make. So yeah, we learned that the hard way today. I'm wondering, could you give like a thumbs up or some sort of emoji if you feel like your group figured out your circuit? So, or you can type in the chat.
I'm seeing lots of thumbs up.
Sort of more or less, should we, I mean, Eric, what do you think? Should we try to scramble, shuffle, and do a quick, or should we debrief together? You're muted, Eric.
Yeah, I think we can, I don't know, I guess we could take a show of thumbs up or thumbs down, what folks want to do. I think it might be helpful for people to, I don't know, it might be useful for people to have a little bit more time or to work on their circuits, or maybe they want to just cross-pollinate and check in with people looking at other ones. We could also
the shuffle exercise would be, we would then reform groups and you would be in a group with people who studied the other bendies, as well as someone who studied your bendies. So that's where the jigsaw, this is what's called jigsaw activity, where each member of the new team has their own information and you have to be able to share it to be able to answer a question. Someone's voting for debrief. So in groups or debrief where we get to walk through all of them would be helpful. Yeah, so we could do that. So we could sort of go bendy by bendy and ask what people found. So should we start? Who wants to, Eric, do you want to stream?
Yeah, okay. Yeah. Let me, I'll share my screen.
Or we could even have somebody who's presenting, like just somebody who did like Bendy 1, they present and then they can go through.
That sounds good.
But I don't know that anyone actually drew them out on the slides that I can see. So I think I can maybe just demo that for folks, like, and show you how we usually show students how to do this in class and then before sending them into the breakout rooms, which is what the step we forgot to do. So I think I'm gonna try that. Okay, so again, as Liz said, I had changed the synaptic strengths and made a couple other changes to the pacemaker neurons in my bendies in my class, and I renamed them bendy 501, 503, and 505 and forgot. And in that renaming, they got some of the cells changed. And I didn't realize, I never used bendies 1, 3, and 5, so I didn't know they had different cell types.
Eric, go to slide 3. This group actually
you did do it.
Renamed their, they made an updated diagram and they have diagrammed their connectome. So would someone from group 1 like to talk through what you found?
I can if the others don't want to. So we basically went through and ablated things one by one and saw how the circuit changed. And we noticed that, so if you excite LOL, then boo goes completely silent. And if you excite boo, LOL goes completely silent. So we have a reciprocal inhibition there, it seems. They both seem to be pacemaker neurons because when you turn off the action potentials, you can still see sort of regular EPSPs happening. And when you ablate LOL, J can still have some activity, but significantly less. Same with the boo to rad. If you ablate boo, you still see activity in rad, but significantly less. It looks like one of those always on neurons that boo sort of pushes further. So that's where we got so far. I didn't know there could be more, and we talked a little bit about how, like, when we think about neurons, we often think like, oh, well, the same neuron won't have both excitatory and inhibitory projections, but both LOL and BOO do. So there's a part of us that sort of questioned like, oh, well, maybe there's something wrong there, or we're missing some part of the circuit because we weren't sure if neurons could have both flavors.
Yeah,
It's
that's
been an ongoing conversation between me and Eric. Like, players really want there to be able to be two, but like, as people know, like usually neurons only have like one type of neurotransmitter, which like that one neurotransmitter could be excitatory in one context and inhibitory in another. It's not impossible.
Yeah.
Definitely.
It's definitely exists
In many animals.
in some animals,
We
not
like-
mammals.
We don't like mammals so much.
But then a lot of mammals also do release more than one neurotransmitter. Maybe most of the time they're mostly excitatory, but it's not to say that there isn't co-transmission in mammalian neurons as well. So it's not that far from biological reality-ish.
Yeah, I also floated the idea that like maybe it has co-transmission, but J and BOO just express different receptors, right? So
Mhm. Yeah, so we do, I made some creatures that had, sort of avoided this. So I just made inhibitory interneurons to have that sort of half-centered alternating pattern without having that sort of, we had the core pacemakers be excitatory, but then they were inhibiting inhibitory interneurons that closed the loop. So you can make more realistic circuits if that is appealing to you, and it bugs me, so I usually do, but this we liked for its simplicity. And most of the students who are introductory haven't been taught, the sort of fallacy that one neuron, one neurotransmitter, so they don't make that assumption and get confused. But it's a really important point. Yeah, anyone else working with BenD1 have?
Gal, do you want to talk about the TTX experiment?
Yeah, it's the first thing we did. We just recorded from everything and put TTX on. And so we knew who the pacemakers are. Assuming that it's a pacemaking mechanism and not some network mechanism that gives you some starting points. That was the first experiment we did. And many of the other experiments was ablate everything and record from two things and stimulate one and see what, and then stimulate the other. But there were definitely, everybody was doing different things. So it was a little bit hard I'm trying to imagine the students doing that and trying to collect the knowledge from 4 people playing with these things. I think it's great. I think it will make them think a lot.
So I think
I like this activity.
the advice that we give in our class and the sort of like, I think the structure that Liz laid out in the video was that they're acting as a team, in the lab. So whether they're doing this in person or on Zoom, one person is going to stream and share their screen, and they're going to be doing the experiments. One person will be note-taking on the slides. Another person will be suggesting experiments that the streamer will then do those experiments. And so there's a single activity at any moment. So we didn't sort of make that clear, but I think it worked very well where the students were like saying, oh, Liz, you're driving Crescent Loom. Can you stimulate BOO for me and record J so that we can see what happens there? And then Olive would be taking notes and saying, okay, experiment number 1, record, stimulate this cell, record the other cell, see what happens, and take a screenshot and put that data in there. So I think for students to be working independently on that, depending on their level, I think would be a bit confusing, and getting them all to meet the same conclusions would be difficult. So I think having group work is pretty useful, and sort of dividing up activities or roles in that team.
Should we contrast BenD1 with some of the other bendies now?
Yeah,
How about BenD3? Anyone want to talk about their bendy 3 connectome.
So I guess I will say a thing or two, if that's okay. Yeah, we did not get as far as the other group, and I don't think we came up with a tentative circuit. We did do some of the same things with TTX and silencing cells by hyperpolarizing them. And we came to the similar conclusion that LOL and Boo were probably endogenous bursters, because knocking out the spikes with TTX was able to, they were still, by hyperpolarizing one of those two cells, you could reset the rhythm so that they weren't in synchrony anymore. Initially, we thought that that those two might be mutually excitatory. Yeah, that's, I think, what we thought they might be, was mutually excitatory. And I don't think we really we didn't figure out how they were connected to the other two neurons that were over to the left of those two. We sort of got slow moving on the two on the right.
Yeah, did anyone else observe mutual excitation between LOL and Boo?
Yeah, our group came to the same conclusion that LOL and Boo were mutually excitatory. And then we also hypothesized that LOL excited J and Boo excited COT. And that was, I think, our complete circuit.
There's no inhibition anywhere, in our opinion, which is why the poor little bugger just stinks at swimming.
So tell us more about that. Like, why would that circuit produce not great swimming?
So ideally, right, you would want sort of that reciprocal inhibition so that they are going in alternating patterns. And we could not find any way to successfully get them to alternate, but we may have just not had enough time. But
yeah, any other comments about Bendy 3?
I'll add to that with regard to the lack of inhibition. The other element, of course, is the speed at which the neurons are firing in Bendy 3, because of J and COT, as they're on this diagram, are both also firing very rapidly. And so the muscles, so there's not enough time for the tail to really, so those muscles are just doing a real fast flagellation. And therefore, the slower pace from LOL and Boo doesn't actually make it through to allow it to have a nice swimming motion.
I have a question about this one and Bendy 1. You know, if you put TTX, whatever, and you record from J or RAD, one of the ones that are driving the motor neurons, the membrane potential is kind of jiggling around a little bit, right? And that's kind of the only reason that this thing actually goes anywhere, because there's some randomness. Is that something that's set at some point when you build it, or just?
Yeah, good question. Let me actually.
I have it open right now if you want me to.
You do?
Just,
okay, go ahead.
Yeah.
Sure.
So this is actually going to be Bendy 1. I opened it up. So indeed, we see the reciprocal inhibition. And yeah, so this is, I'm just going to like stop any input. So this is one of the basic neurons. And the only option that basic neurons have is how much jitter to add. Default is slight, but if you turn it up to some, you see it going up and down, and like it'll sometimes fire an action potential once you add an axon. So like there's a couple, and then lots of jitter gets it up above the membrane potential, or like the threshold frequently. So this one does indeed have a lot of jitter, but then these pacemakers seem to kind of like increase the level of. Yeah. Short answer, yes.
Got it.
Yeah, so that was something that this unfortunately led to a bit of the confusion today, because I had added some jitter to the neurons and the creatures that I made to the pacemaker neurons, because I found that when I blocked inhibition with bicuculline, the two pacemakers would often just stay in antiphase. And so the students didn't realize that they were reciprocally inhibiting each other because they were so perfectly timed, right? And so when I added jitter, all of a sudden they very quickly fell out of phase, and then they would go in phase and out of phase, and it was very random. So I added that jitter to those neurons when I made the animal, so that it would be very obvious that when you block inhibition, they go out of phase with each other. So that's something that, you know, I learned through experience, that, oh, a little bit more jitter. And this was something that we sort of requested because of Olive, because we were like, well, they're too similar. We need to add a little bit of noise. And that's when that option came in. So you sort of learn by trial and error, which can take a long time, right? Which is why we want to have some things available out of the box for you that have been, tested in the test kitchen and we know work, because we don't want everyone isn't going to want to spend a huge amount of time tinkering with how much noise should this cell have to illustrate the point that I'm trying to make. But it is a tool that is available. Should we
Bendy 5, we
do
should talk
Bendy
about Bendy
5? Yeah.
So I see Ryan is saying no crosstalk between Lowell and Boo. I don't know if
Yes.
we want to share. Yes.
Sorry. That's
That is
basically what
true.
our group found.
Yeah. Yeah. So that's a case where I think in one of the earlier videos, basically you've got like the left side and the right side of the circuit, but the left and the right side don't talk to one another at all. I'm seeing lots of comments in the chat about like not thinking about the behavior at first. And so then as educators, we can think about where to introduce that. So when I ran this activity, the racetrack didn't exist yet. So I just had students qualitatively describe the swimming first. Then they solved the connectome, and then they had to sort of revisit, okay, now can you explain to me why you saw the different behaviors that you did based on the connectomes that you found? Next time I run this, because we have the racetrack, I may have them collect data, graph it, run multiple trials to be more, to be perhaps quantitative about it. But there's nothing wrong with, just watching and sort of explaining what you see.
So which top one is Bendy 1?
That's Bendy
that
1
right?
is on the top.
This is Bendy 1.
3 is pink and Bendy 5 is purple.
So Bendy 5 often looks just like Bendy 1, and it often looks just like Bendy 3, depending on whether the motor neurons or the pacemaker neurons happen to be in phase at that moment or out of phase. One thing that I have noticed, though, is that Bendy 3 actually swims in a very straight line because it never bends a lot, because the pacemaker neurons are always active at the same time. It often does pretty well. But yeah, so this is something that I had the students come back to a couple times after they went into the breakout rooms and shared their findings. And then, then we came back and looked at this again. And I think it helped sort of clarify, like, okay, that's why Bendy 1 is just always left, right, left, right, left, right. Whereas Bendy 5 is really unpredictable. And Bendy 3 is just always like that.